Welcome to Learnpedia. Score more and rank better in JEE and NEET. Now let's see if you can answer this important question. If you think you got the answer, then post it in the comment section below. To know the best way to answer this question, continue watching this video.
Basis of type of blood that is pumped through the heart. Hearts are divided into two types. One is venous heart. It receives deoxygenated blood only. Example, fishes. So actually, as heart receives deoxygenated blood from all body parts except gills. That is why it is called a venous heart. It always pumps deoxygenated blood to the gills for oxygenation. Second one is arteriovenous heart. It receives deoxygenated blood from the body and oxygenated blood from the gills or lungs. And this type of heart is called arteriovenous heart. Examples are amphibians, reptiles, birds, and mammals. We can classify the heart on the basis of origin of impulse also. Based on this, we can divide this into neurogenic heart and myogenic heart. Let us see the difference between these two. In neurogenic heart, the heartbeat is initiated by a ganglion situated near the heart. Whereas in myogenic heart, heartbeat is initiated by a patch of modified muscles. They are called pacemakers. Number 2, the impulse of contraction originate from nervous system. And here the impulse of contraction originate in the heart itself. 3, the heart normally starts beating immediately after removal from the body. Therefore, heart transplantation is not possible. Here, heart removed from the body continues to beat for some time. Therefore, heart transplantation is possible. Examples of animals with neurogenic heart are some annelids and most of arthropods. Here, the heart of molluscans and vertebrates comes under myogenic heart. On the basis of structure, the hearts are of following type. You can see tubular heart in insects like cockroach. Especially in cockroach, it is a 13-chamber tubular heart present on the dorsal side of the gut. Pulsating vessels. Examples are annelids, holothurians, amphioxus. Some blood vessels, they contract and relax. It is a type of pulsating movement. These are called pulsating vessels. And chambered heart. Heart is divided into chambers in the case of vertebrates and molluscans. So just now we saw in vertebrates and molluscans, the heart is myogenic heart and also chambered heart. Ampullary accessory hearts. The branchial heart of cephalopods, example are octopus, insects, heart bulbus of amphioxus, lymph hearts of frog, they all come under ampullary accessory hearts. The form, structure and function of heart exhibit much variation in case of fishes, amphibians, reptiles, birds and mammals. So let us start with the single chambered heart in the case of cephalochordates. So in cephalochordates, a true heart is lacking. A part of ventral aorta present below the pharynx become muscular and contractile. So some zoologists consider it as a single chambered heart. Here let us have a look at progressive modification of heart from primitive to higher chordates. So let us see the evolutionary trend. First, a cardiac tube forms chambers due to constrictions. Then each chamber tends to divide into two separate chambers. And then finally formation of partitions. And gradually heart shifts from behind the head. Example, fishes and amphibians. And this one is near to the gills in case of fishes and amphibians. Whereas in the case of amniotes, that is reptiles, birds and mammals, it is pushed into thoracic cavity or shift into thoracic cavity with the elongation of neck and development of lungs. This is how a simple single-chambered heart ultimately developed or evolved into four-chambered heart. Let us see two-chambered heart and single circuit venous heart in the case of cyclostomes. Here it is the simplest condition in vertebrate heart, as seen in the case of cyclostomes like hagfishes, lampreys, and their larval form, that is ammocyte larva. Actually, it shows a series of four chambers, that is sinus venosus, then into atrium, ventricle, and a small conus arteriosus. These are all present in a sequence, and generally this heart is present in the body cavity along with other visceral organs. Whereas in Elasmobranchs, the heart of cartilaginous dogfish is a typical and generalized for most of the fishes. Actually, it is muscular and dorsoventrally bent S-shaped tube. It consists of four chambers which are arranged in linear sequence. So in this case, there are only two chambers, that is atrium and one ventricle. These are the true chambers of the heart. That is why the heart in fish are considered as two-chambered heart. It contains accessory chambers, they are sinus venosus and conus arteriosus. Let us see the structure of two-chambered heart in this generalized cartilaginous fish. Thin-walled sinus venosus receives blood of body through larger veins commonly called hepatic sinuses and common cardinal veins. They are also called Cuvierian ducts. And this sinus venosus chiefly serves as a reservoir of blood, and it opens anteriorly into the atrium through sinoatrial aperture, and it is guarded by a pair of valves. Then atrium is a large, thin-walled, elastic, muscular chamber lying dorsal to the ventricle, and it opens ventrally into the ventricle through an atrioventricular aperture, which is also guarded by a pair of valves. Then blood reaches the ventricles. Ventricle has very thick walls, and it opens into a muscular tube of narrow diameter that is called conus arteriosus, and this has a series of semi-lunar valves. All valves of heart, they prevent the backward flow of blood or regurgitation of blood. Here the heart of fishes is enclosed in a small pericardial cavity and separated from general coelom by a transverse septum. Later, this conus arteriosus becomes continuous with ventral aorta, and in Elasmobranchs, transverse septum is perforated by a pair of openings through which pericardial cavity communicate with coelom. That is how the heart of Elasmobranchs is a venous heart and two-chambered heart. Teleost fishes, the heart of bony fish, resembles in all respects that of Elasmobranchs. In some chondrosty, example Polypterus, and holosty, example Lepidosteus, conus is fairly long with numerous valves. In case of Amia, conus arteriosus and its valves are reduced. In teleost fishes, during evolution, the conus arteriosus is reduced, even may be absent and fused with the ventricle. So this one is the ventricle. Instead, a part of the ventral aorta in contact with this conus arteriosus greatly enlarged in size with a thick muscular wall. This is called a bulbus arteriosus. So, bulbus arteriosus is an enlarged part of ventricle which is thick, muscular. That is why it is called bulbus arteriosus. It is inflated like a balloon when ventricle contracts. So remaining parts are similar to that of Elasmobranchs, like presence of one atrium accessory tube-like sinus venosus, then hepatic sinuses and coherent ducts. These are common to all fishes. So now, the blood passing only once through the heart is non-oxygenated one. It is pumped to the gills for aeration before distributed to the body. Such a heart is termed as a branchial heart or venous heart. Circulatory pathways. Heart in fishes is called venous heart. It consists of two chambers, one atrium and one ventricle. Blood from different body parts is collected by the veins and pour it into a bag-like structure called sinus venosus. From there, blood enters into the atrium and then into the ventricle. From the ventricle, it is pumped through ventral aorta to the gills. As blood passes only once in a circuit, it is called single circulation. Origin of heartbeat. Initiation of heartbeat is under the influence of special bundle of cardiac muscles called nodal tissue. It is also called arteriovenous cells. They act as pacemakers and set the rhythm for entire heart, and they form conducting system. As you know that mammalian heart is a myogenic heart, that is, the heartbeat originates from a muscle in the heart. Here I would like to tell something about the vertebrate heart, that is myogenic heart. In myogenic heart, the heartbeat is regulated by autonomic nervous system, that is parasympathetic and sympathetic nervous system. It means that if the heart is innervated, the heartbeat will be rhythmic at 72 times per minute. But this heart will not adjust the rate of heartbeat in case of any stress. Pacemaker. SA node is called the natural pacemaker. It is present in the right atrium near the region where the superior vena cava opens. Actually, this node is the place where the heartbeat originates. So this is called pacemaker, and it is richly supplied with blood vessels, and the wave of contraction originate from it and spread all over the heart. SA node is responsible for generating an electrical impulse once in every 0.8 seconds in a normally healthy adult. It generates an impulse at the rate of 80 to 100 per minute at rest, and this impulse stimulates the atrial valve to contract. Then impulse will travel from right atrium to left atrium via an internodal fibers called Bachmann's bundles. Actually, this type of heart is seen in case of molluscans and vertebrates. In case of annelids and arthropods, the heart is stimulated by nerve fibers located close to the heart. Heart is known as a neurogenic heart. Then let us have a look at temporary pacemaker. It is used in emergency such as cardiac arrhythmia control. Example, bradycardia, that means slow heartbeat. Then the permanent pacemaker is used in atrioventricular block or AV block and SA node dysfunction. In the patients of Stokes-Adams syndrome, where it is a sign of ventricular escape or ventricular systole, and also it can be used where atrial impulse suddenly fails to be transmitted to the ventricles. In such patients, the permanent pacemaker is implanted. Then now we'll look at the artificial pacemaker. It is an electronic device which regularly sends small amounts of electrical charges that stimulate the heart. The artificial pacemakers consists of a pulse generator containing cell, that is solid state lithium cell, to produce electrical impulse. The lead in the form of a wire will transmit the impulse, and an electrode which is connected to the portion of heart where impulse is to be transmitted. Conduction speed in cardiac tissue. Sinoatrial node 0.3 meters per second. Atrial pathway takes 1 meter per second. Atrioventricular node, the speed of conduction is 0.3 meters per second. In case of bundle of His, conduction speed is 1 meter per second. In Purkinje system, it takes 4 meter per second. In ventricular muscles, it takes the same time, that is 1 meter per second. In atrial muscles, the speed of conduction is 1 meter per second. Heart sounds. These are caused due to sudden closure of the valves of heart. The sounds produced by the beating of heart can be heard by placing ear against the chest or by using a stethoscope. And the stethoscope was invented by René Laennec. There are mainly two sounds in a normal adult. First heart sound, that is lub sound. It occurs at the onset of the ventricular systole and is caused due to sudden closure of AV valves, that is bicuspid and tricuspid valves, and the ejection of blood from the ventricles. Actually, it is a dull sound and longer sound, and it is heard as the word lub. The second heart sound, that is dub sound, it occurs at the onset of ventricular diastole and it is caused by the sudden closure of segulunar valves of the aorta and pulmonary artery towards the end of the ventricular systole. This prevents the back flow of blood into the respective ventricles. The sound is highly pitched and louder, sharper and shorter in duration. Here, what is a heart murmur? When the semilunar valves are injured, a soft hissing noise, lub sound, is heard instead of lub sound. This is called heart murmur. The blood can leak back from the pulmonary trunk and aorta into the ventricles. Third heart sound. Generally, it occurs during first rapid filling stage, that is during joint diastole. It corresponds to the filling of ventricles rapidly. Then fourth heart sound. It occurs during atrial systole, especially during second rapid filling stage. Actually, it is a rumbling sound. So, the sequence of sounds are as follows. That is lub, dub, pass, and lub, dub, then pass, and so on. Especially here, the S3 and S4 are faint sounds and not heard using the stethoscope. Heart sounds provides valuable information about working of valves. A defective or damaged heart valves lead to backflow of blood either from ventricles to aorta or from aorta to ventricles. Such defects are detectable as abnormal hissing sounds called murmurs. So we have already discussed in the previous slide. These defective valves may be replaced or repaired surgically. Phonocardiogram is the instrument used to magnify and record heart sounds. Then heartbeat. It is the rhythmic contraction and relaxation of heart. Each heartbeat includes one systole, that is contraction phase, and one diastole, that is a relaxation phase, and it helps the heart to distribute and receive blood to and from the body. In a healthy person, heart beats for 70 to 75 times per minute. So on an average, goes to 72 times. Generally, as smaller animals have higher metabolic rate, their heart rate is higher than larger animals. So an elephant has normal heart rate of about 25 times per minute, whereas a mouse has a normal heartbeat of several hundreds per minute.
I hope you can now answer the question. Take a look at the solution now. Use the comment section below to post your feedback, queries and questions. LearnPedia's JEE and NEET prep tools contain over 4,000 videos and over 20,000 questions. You can access them online through our website or offline through an SD card or a pen drive. To buy now, visit www.learnpedia.in. You can also try a free demo of the product before buying.